Good evening, Lamai. Right, let's start the class. Last day, actually, we were discussing about carbon-carbon bond making, right? Actually, elongating our carbon skeleton or the carbon chain by more than 1 unit. That was the discussion last day. We had started that discussion, right? And there we had discussed about two techniques, right? So, how to use the Grignard reagent, the Grignard method, of elongating the carbon chain by more than 1 unit, and secondly we had discussed about how to use the acetylide method, the sodium acetylides, to come up with to fulfill that purpose, right? To elongate our carbon chain by more than 1 unit, right? So today we are going to start with the third technique available to elongate our carbon chain by more than 1 unit, right? That is referred to as the condensation method. So let's begin with that, the condensation method, right? So basically the condensation reactions can be carried out using aldehydes as well as ketones, right? Let's discuss about the theory behind the condensation method, right? Then we can go towards some conversion, right? First, the theory, right? So as I mentioned earlier, condensation can be carried out using aldehydes as well as ketones. If we are to carry out the condensation method or condensation technique with the use of aldehydes, we referred to it as the aldol condensation. Aldol condensation, right? So if we are using the ketones to do the condensation, right, we refer to it as the ketol condensation, right? Let's start with the aldol condensation, right? How to use this condensation to come up with carbon skeleton where you have added more than one carbon, right? Okay, let's start with that, with the aldehydes, right? So first thing we are going to discuss here is the aldol condensation. Aldol condensation, right?
Recording in progress.
Aldol condensation, right? Let's start with this, the aldol condensation, right? So when it comes to aldol condensation, as I have mentioned earlier, the aldehydes are used, right? So it is like this, the thing carried out like this. So if you are to add some NaOH to an aldehyde like this, if you are to add some NaOH to aldehyde like this, see, this kind of aldehyde. So if you are to add some NaOH to this aldehyde, right, you have aldehyde and you are adding the aqueous NaOH. So if you are to do so, you will come up with some compound where more than one carbon is added. Basically the carbon number, right, will be increased by 2 units as you are using a compound with 2 carbons, right? So basically carbon number, right, will be multiplied by 2. The carbon number will be multiplied by 2 as you are using 2 carbon aldehyde as a starting material. You will come up with a 4 carbon situation. Let's see, let's discuss how to come up with the product here. So it's like this, writing the product is like this, right? First Lamai, just write this compound. This is how to write the aldol condensation product, right? First write this compound. The same compound, right? The same compound without this 5 bond. Actually by removing this 5 bond, there is a 5 bond here, no? sigma and a phi, no? One of the bond is phi, no? Just remove this phi bond, right? Remove this phi bond and write the compound, right? So it is going to be like this. Writing the compound by removing the phi bond. So that the carbon is lack of one bond, no? So carbon is not with 4 bonds now, no? As you have removed the phi bond there. Right? So for that, just add the alpha carbon of your aldehyde. So a new term, what this alpha carbon means. Yes, the alpha carbon means, Lamai, the alpha carbon means, so that is the carbon adjacent to this carbonyl carbon. This is a carbon adjacent to this carbonyl carbon. So this is your carbonyl carbon. The carbon with the carbon oxygen double bond, it is referred to as the carbonyl carbon. The adjacent carbon to that is referred to as the alpha carbon. Adjacent carbon to that is referred to as the alpha carbon. So we are supposed to connect the alpha carbon to that carbon, by removing one of its hydrogen. Just right, connect this alpha carbon to that bond, right? So it is going to be then, after removing one hydrogen, it is going to look like CH2. After removing one hydrogen, it will be CH2 and the rest. See? This is alpha carbon, no? This is alpha carbon. Just connect the alpha carbon. To this carbon, right? So you have removed one of the hydrogens, no? That hydrogen is then going to be written here. So then you need 2 bonds, no? To come up as a neutral oxygen. So just add that removed hydrogen, that alpha hydrogen here, right? So this is your compound. I'll write another one to give you a clear understanding. So this is how you are supposed to write the product of the aldol condensation. So this product is known as right, alpha beta. This product is known as beta-hydroxy carbonyl compound. Beta-hydroxy carbonyl compound. The product of aldol condensation is known as the beta-hydroxy carbonyl compound. Why it is said so? So the carbon adjacent to the carbonyl carbon, is referred to as the alpha carbon. The next carbon is beta carbon, then the gamma, like that. That is the notation. The carbon just connected to the carbonyl carbon is the alpha carbon. Next one is the beta carbon. Next is the gamma carbon. So here you clearly see at the beta carbon you have some OH group. That is why this is referred to as beta-hydroxy carbonyl compound. Right? That is the name given to, right, these aldol condensation products. Right? So beta-hydroxy carbonyl compounds are formed by aldol condensations. Right? I'll come up with another example. Right? So another one. Before that, let's come up with the ketone condensation as well. Then both are the same, both carrying the same technique, right? So we'll do the ketone condensation as well, and then I'll come up with more examples, right? So let's do the ketone as well. So ketone condensation, where the ketones are participated. Right? See, this is the ketone condensation, right? Okay. So let's say you have this ketone. So starting with this ketone. The ketone, no? This is your ketone, right? So you are adding aqueous NaOH. Let's try to come up with the product. You are adding aqueous NaOH to your ketone. Let's try to copy the product. So it is written like this now. First write the same compound. First write the same compound by removing the 5 bond of your carbonyl bond. By removing the 5 bond of your carbonyl bond, just write the same compound. See, CH3, C, this becomes O after removing the 5 bond, and the CH3 here. I just bent this thing and written. Right? Then to that carbon, just connect the alpha carbon of your carbonyl compound, the alpha carbon of your ketone in this case. This is the carbonyl carbon. The carbon adjacent to that is the alpha carbon, so you can connect that thing. Both of these are alpha carbons, right? Even these and these, both are alpha carbons. Both carbons are connected to the carbonyl carbon, both alpha carbons. So let's connect this one, this alpha carbon. So after removing one of the hydrogens there, you have to remove one of the hydrogens, right? Without that, it will exceed the 4 number of bonds now. So you have to first remove one of the hydrogen, and it will be connected to here. The removed hydrogen will be connected to here. Then connect this carbon. So this is the connection. I just connect that carbon, and that carbon is with 2 hydrogens, as you have removed one of the hydrogen to here, and the rest you have C double bond O and some CH3. See, that is how the product looks like. So this is known as, you clearly see, this is the alpha carbon, this is the beta carbon, this is the carbonyl carbon, right? The carbon just connected to that carbonyl carbon is the alpha carbon, and then the beta carbon. So you have you can clearly see at the beta carbon you have a OH group. So that is a beta-hydroxy carbonyl compound. Right? This is alpha carbon, right? So again, it's a beta-hydroxy carbonyl compound. So with the aldol condensations or the ketone condensations, you will get the beta-hydroxy carbonyl compounds. Beta-hydroxy carbonyl compounds. Right now? So that is the idea, right? So with aldol and ketone condensations, you get the beta-hydroxy carbonyl compounds. Right now? So this is the aldol condensation and the ketone condensation. You clearly see you're starting with 2 carbons here and you are ending up with 4 carbons. Basically with aldol condensation and ketone condensations, the carbon number will be multiplied by 2. The carbon number will be multiplied by 2. See, here as well, you're starting with 3 carbons and ultimately ending up with 6 carbon situation. Carbon number is multiplied by 2. Starting with 3, ending up with 6. Right now, this is the aldol condensation. Let's do some more examples. These things are written in your tute. You can see that, right? So I'll do few more examples to grab this idea clearly, to write the product clearly. But you should be able to write it at once now. See, let's go for a few more exercises, right? Before going for the conversions, let's try to come up with, try to practice this thing, right? Okay, see. Some examples. Let's go to these examples. Right. So let's say you have this one, this aldehyde, right? And you are adding aqueous NaOH to that thing. Let's come up with the products. What do we need to do here? First of all, write the compound without the 5 bond here. Without the 5 bond here, just write the compound and put some H to the oxygen. So without the 5 bond, converting this into OH, just write the compound. So CH3 CH2, C, OH, and the hydrogen, this hydrogen, right? Okay. Then to that remaining bond, just connect the alpha carbon of this compound by removing one of its hydrogens. Just connect the alpha carbon of the same compound by removing one of its hydrogens. So this is the carbonyl, this is the alpha carbon. Just connect this carbon by removing one of its hydrogens. Let's do the stuff, right? So this is the carbon I'm going to connect. So by removing one of the hydrogens, it becomes CH. And then you have the rest, COH, right? This stuff, right? CH, COH. We had removed one of the hydrogens, right? Then this thing, there is a CH3 group connected to the alpha carbon, so that it can be written like this. Just bend this CH3, and connect this one. That is how we are supposed to do. Just bend this CH3 like this and connect this one. Connect the alpha carbon to the carbonyl. Then you are done. Right now? So that is the idea. Right? Okay. So again, you can clearly see this is your alpha carbon. Right? At the beta carbon, you have OH. At the beta carbon, you have the OH. So it's again a beta-hydroxy carbonyl compound. Beta-hydroxy carbonyl compound. So if you had written this thing correctly, if you had written the product correctly, you could clearly see only one carbon which connects the two carbons, only one carbon which connects the aldehyde carbon and the ol carbon. There's only one carbon which connects the aldehyde carbon and the ol carbon, which is the alpha carbon. Only one carbon appears between the two guys to connect these two, the aldehyde carbon and the ol carbon. Actually, that is why this is referred to as the aldol condensation. You have aldehyde section and a ol section, alcohol section. So this is referred to as a aldol condensation, right now. So that is referred to as the aldol condensation product in this case, right? Okay, right. See, let's try to come up with another example for aldol condensation. See, I'm going to use some asymmetric ketone here. Not like in the earlier case, some asymmetric ketone. See how we are supposed to come up as the product, right? Just at the end, I'll check you. So what we are supposed to do? First, write the same stuff without the 5 bond here and adding a hydrogen here. So CH3, CH2, writing the same stuff with the OH here, right? And without the 5 bond. And this carbon is with a CH3 group. Just bend that thing. Right? Then I'm going to connect. First I'm going to connect this alpha carbon. To that carbon. After that, we can connect. We can go with this one as well, because it's a asymmetric ketone. So first let's go with this carbon, right? So just connect this one. Just bend this stuff. Just bend this CH3 like this and connect this one. Connect this one to the alpha carbon there, right? So this is the connection. I have just bent this CH3 and just connect this one to this carbon, right? So you will come up with CH, only one CH because one hydrogen is removed to give the H here, and the rest like this. You have the COCH3 and just write this one as well. The CH2 group you have bent, right? So you can write that this in here or here at the top or bottom. You can write that, right? No worries. From the top or bottom, you can write that CH2 group available with the alpha carbon. Right now, this is your compound. This is one of the products which will form if you are to do the ketone condensation with this ketone. What is the other product? What is the other product? So not only this carbon, but also this carbon can be connected to the carbonyl carbon to give you the product. I'll come up with that thing as well. See, first written this thing, or else I'll do it again, right? So to get the clear idea, see, I'm going to do it again, right? For the ones who had not with me at that point, right? So see, it is like this. So first write the same thing. Right? First write the same thing. Like this: CH3, CH2, C, OH, and a CH3. Just write the same thing by removing this 5 bond and adding some H here. Then to that, connect this carbon, connect this alpha carbon by removing one of the hydrogens. So it is going to be CH2. After removing one of the hydrogens, it will be going to be CH2, right? CH2. Then towards here I am going towards, right? So CH2, and to that you have a C double bond O, and to that thing you have a CH2 and a CH3. CH2 and a CH3, right now? That is how we are supposed to copy the product, right? That is the second product which we will be able to get by doing this kind of a condensation, right now. That is the idea. That is how the aldol condensation is to be carried out. That's how we are to carry out the aldol condensation. So here when we are doing this aldol condensation, you clearly see the two carbons connected. The two carbons connected to each other are the carbonyl carbon. From one section is the carbonyl carbon, and from the other side it is the alpha carbon. So carbonyl carbon and the alpha carbon, that is the connectivity in this case. This one is a carbonyl carbon, and this one is the alpha carbon. See, the connectivity is supplied by the carbonyl carbon and alpha carbon, right? First write the compound, right? And to the carbonyl carbon, your alpha carbon is connected. That is the connectivity for our conversions, right now. Let's use this one. Let's use this technique to come up with more number of carbons, or to add some more number of carbons to your starting compound. Let's try to use this one. Okay, I think you are clear with the technique, right? Let's try to do 1 or 2 example questions, right? Okay. So example conversion. Right, so you are with this one, and you are starting with this, and you are supposed to produce this one. This thing. Right, okay. Let's try to do this conversion with the use of aldol condensation, with the use of the condensation techniques. I don't know whether it is the aldol or the ketol, right? Both are the same, right? But I don't know up to now, right? Anyway, let's use one of the condensation techniques to come up with this carbon skeleton. That is the first idea, no? So when we are doing a conversion, our first goal is to come up with the correct carbon skeleton. That is where we are supposed to use the condensation technique, right? To come up with the correct carbon skeleton, we are supposed to use the condensation technique now, right? Okay, first analyze the starting compound and the product we need to come up with, right? So here you are starting with a you are starting with a 3 carbon compound. You are starting with a 3 carbon compound, right? You are starting with a 3 carbon compound, and with this one, you are with a 6 carbon compound. Here you are with a 6 carbon compound. Started with a 3 carbon compound, and now you are with a 6 carbon compound. So carbon number multiplied by 2. Carbon number multiplied by 2. So you can think of a condensation technique here, right? Okay, let's discuss. So first of all, what we need to do, as in earlier cases, first thing to do is actually we have to divide this larger compound, the 6 carbon compound, into two blocks containing 3 carbons. Containing 3 carbons each, we have to divide this larger compound into 2 blocks, right? Why 3 carbon blocks? Because we are starting with a 3 carbon compound, right? So first of all, divide this 6 carbon compound into 2 blocks containing 3 carbons. So the only available division is from here, right? I have just divided the starting compound into 2 blocks containing 3 carbons, right? Okay, like in the Grignard case, like in the Aldol techniques, the same thing is done, right? Okay, after this we are supposed to copy the 2 blocks, right? So actually one block, both the blocks are coming with the carbonyl compounds. Both the blocks are coming with the carbonyl compounds, as we are going to use the Aldol technique. And see, the one carbon, this carbon or the other carbon, one carbon is going to be a carbonyl carbon. One carbon is going to be a carbonyl carbon, right? One carbon is going to be a carbonyl carbon, and the other carbon is going to be your alpha carbon. Other carbon is going to be your alpha carbon. That is how the connectivity is done. It's how the connectivity is done. So this is your carbonyl carbon, this is your carbonyl carbon, then this should be your alpha carbon. Is that so? You clearly see, if this is your compound, that means at the center carbon, the carbonyl group is there, that means it's a ketone. So if the center carbon, with the center carbon the carbonyl group is appearing, with the center carbon the carbonyl group is appearing, definitely this is going to be the alpha carbon. So we are happy, right? This is going to be the alpha carbon, right? I'll just write it as alpha carbon. So this is the carbonyl carbon and this is the alpha carbon. That is the connectivity, right? Okay, let's write the 2 compounds. Right? No need to write 2 compounds, just 1 compound, no? So let's write the stuff. So what is the carbonyl compound here? This is the carbonyl carbon. See, this one is the carbonyl carbon. That is how we are supposed to write the carbonyl carbon. And to that carbonyl carbon, we have 2 CH3 groups. Just the R groups are added, right? Just what we are writing is the R groups. 2 CH3 groups, right? Okay. So this block is coming from this. This block is coming from this. As well as this block. Why is that? If you are to think of the alpha carbon of this one, that is your corner carbon, no? That is done. So actually both the blocks are coming with this one single compound. If you are to add some NOH to this one, you will get the carbon skeleton. Let's write that thing. Let's write the same thing with some OH here and removing this 5 bond. Let's write that thing. So CH3, some OH here, after removing the 5 bond, the OH here, and this thing should be bent like this. And to that carbon, just connect the alpha carbon by removing one of the hydrogens from it. So that is going to be CH2 then. By removing one of the hydrogen, this is going to be CH2 then. and COCH3. Right now? So that is your product. That is your product. See, you are clearly seeing the carbon skeleton is done. The carbon skeleton is done. 1, 2, 3, 4, 5 carbon chain with some branch at the second carbon. The CH3 branch at the second carbon. The carbon skeleton is done. So actually this is your heart of the question. So actually you have solved the question, right? So now we need to come up with some simple makeups. Now we need to come up with some simple makeups. What are those? First we can make this one from here, right? To that. To do so, first we can convert this stuff to kind of alcohol by just adding some dilute H2SO4 and then addition of some PCC will convert that secondary alcohol to a ketone. Very simple, no? Converting this to here, right? It is not that hard, right? Convert this thing to here. First of all, you can come up with the Clemmensen reduction. You can copy the Clemmensen reduction to get rid of this C double bond O. To get rid of this C double bond O, you can copy the Clemmensen reduction, where you are supposed to add the zinc amalgam with some concentrated HCl, right? So here some special reaction occurs. This is some special thing, right? So the Clemmensen reagent will attack to here. The Clemmensen reagent will attack to here. The Clemmensen reagent will attack to here. And this special thing occurs. Lamai, actually, when you are to add some acid, basically this kind of acid, right? When you are to add some acid, and when you are doing some heating here, what will happen is actually this OH of your beta-hydroxy carbonyl compound, will leave. This is a special stuff appearing with the beta-hydroxy carbonyls, which are the products of the aldol condensation. What is the special situation? When you are adding some acid and heating, right, this OH will leave with one of the hydrogens here. Right, this OH will leave, giving you a double bond here. Basically, a dehydration occurs when you are to add some acid to a aldol product, beta-hydroxy carbonyl product. This is a special thing happens with the beta-hydroxy carbonyl, the product of the aldol condensation, right? So that is also happening with this reagent as you are adding an acid. So let's write the stuff there. So your compound ultimately is going to be like this thing: CH3C, CH3. I write that thing, special thing, as not, right? So this OH will leave with this hydrogen. This is a very characteristic special thing happening with the beta-hydroxy carbonyls. Actually, no need of concentrated H2SO4 or no need of alumina to get rid of a water molecule from the beta-hydroxy carbonyl. It will just happen with the use of an acid. Just the acid is enough, right? So OH and H will remove, giving you a double bond, and one hydrogen will be there, as only one is removed. One hydrogen will be there, and this will convert to CH2. That will convert to CH2. That is the Clemmensen reagent, that purpose of adding the Clemmensen reagent, and the CH3 is there. So that is your compound, right? That is your compound. I'll write about this situation, right? I'll write some comment about this one, right? Okay, this is the Clemmensen's attack. Right? Okay, then we can convert this one to here. By just adding some HBr. will connect, give you the final compound. Right now, it's going to mark only F. The hydrogen will go to here, and Br will be added to the other carbon. So that is how we are supposed to complete the conversion. Not that much of steps, Ramani. So just 1, 2, 3, 4, 5. Just 5 steps. Just 5 steps completing whole the procedure. You see, when it comes to aldol condensations, normally the number of steps are very less, very minimum. With the minimum number of steps, you are able to complete the whole process when you are going through the aldol condensation. That is one of the specialty, one of the major uses, right? One of the major advantages of this technique, the aldol condensation, right? So with very few number of steps, we are able to complete the conversion, right? That is very understood, Lamaya. That is very understood, right? Why? Because only one compound is to made, no? Because only one compound is to made, no? Basically, only one compound is need to made, no? So not like in Grignard or the acetaldehyde methods, not like in Grignard and acetaldehyde methods. In Grignard method, you may have to make 2 of the compounds. Even in the acetaldehyde method, no? You have to make the Grignard and the aldehyde or ketone. So 2 pathways that should be there to make those 2 compounds. So more number of steps will be involved. Even with the acetaldehyde method, you need to produce acetaldehyde at one side, and the other side you need to come up with the alkyl halide. Again, 2 compounds should be made before the connection, before you are to connect the 2 guys, right? But here you just need only one compound to make. Normally 1 compound to make, right? So very limited amount of steps will be consumed to complete the total conversion, right? So in your A-level question, if there is a question like this, to increase the carbon chain by more than 1 unit, and very limited steps are available. If they have restricted you to very few number of steps, basically less than 6 steps. Basically less than 6 steps. If they have limited you to less than 6 steps, most probably it could be through the aldol condensation. It should be done through the aldol condensation, right? That is very important case, right? So when the steps are very low number of steps are involved, most probably the conversion technique could be the aldol condensation, right? So you clearly see that thing. But I'll write some comment here for this thing as well. What was that? It is actually I write the comment here. Yeah, I'll write it here. So it's a special note, right? So I'll write the special note, right? Here. Note is right. The beta-hydroxy carbonyl compounds made via condensation will be easily dehydrated by dill acids, dill H plus and some heat. Very little heat, right? Even 50 Celsius is enough. Very little heat is enough, right? If 50 Celsius is enough, little heat, right? No need of very huge amount of heat as in consider H2SO4 situation, right? So actually what I need to say is no need of extreme regions like conc sulfuric. So no need of conc H2SO4 and heat or alumina for dehydration. For dehydration of these beta-hydroxy compounds, right? All right, but it is what is happening there. So it is like this. So I write the kind of a example. So this is the beta-hydroxy carbonyl. One of the beta-hydroxy carbonyl, right? So if you add some H plus and heat, if you add some yield H plus and heat, what will happen? This OH will remove with this one. This OH will be removed with this one, right? So you will ultimately get this compound CH double bond CH, this thing, right now. So this OH will remove with this hydrogen, right? Giving you a alpha beta unsaturated compound. Giving you a alpha beta unsaturated compound. Alpha beta unsaturated compound. This is your beta-hydroxy carbonyl. And this is the alpha beta unsaturated compound. See, at the alpha carbon and the beta carbon, you have a double bond, the unsaturated bond. Double bonds are normally referred to as unsaturated bonds. So alpha and beta carbons, you have unsaturated bond, right? So this is a special note. Just write that thing as well when you are completing notes. Right now. So that is a special thing happens with the beta-hydroxy carbonyl compounds made via condensation techniques. No need of adding sulfuric or the alumina to dehydrate to release a H2O molecule and form some beta-hydroxy alpha beta unsaturated compound, right? This will occur. So that is what happened here. That is what happened here, right? So that is the star marked case, right? That is what happened here. As you are supplying some concentrated HCl, it will provide that H plus needed and some heat as well when doing the reaction, right? So this thing will occur. So this is a condensation, right? This is a conversion using the condensation, right? So I wish you got some idea here, right? Okay, no? So let's have a think check. With the use of condensation technique. With the use of one of the condensation techniques, let's do this one. Right. First, let's analyze. Let's analyze this one. Okay. So here we are starting with kind of a 3-carbon compound. We are starting with a 3-carbon compound, and we are supposed to come up with a 6-carbon compound. Come up with a 6-carbon compound. Right. So the first thing to do is break these 6-carbon compounds into 2 3-carbon blocks. Right. That is our first thing, right? So as we are starting with 3 carbon blocks, right, first break this 6 carbon compound into 2 3 carbon blocks, right? So if you do so, it will be from here. You need to break this stuff. So I have break this stuff into 2 3 carbon blocks, right? So then these are the 2 carbons. These are the 2 carbons which will connect from the 2 blocks to make this larger compound. To make this larger compound, the corner carbon of the left hand block is to be connected to the center carbon of the right hand block, right? Let's assume that this guy is coming from a carbonyl carbon. Let's assume this is the carbonyl carbon. This is a carbonyl carbon before the the guy is connected. Let's assume this was a carbonyl carbon. This was a carbonyl carbon. See, if that corner carbon is a carbonyl carbon, if your corner carbon is a carbonyl carbon, the second carbon should be your alpha carbon. If this corner carbon is a carbonyl carbon, it was a carbonyl carbon, then this carbon, the center carbon, should be your alpha carbon. Yes, that is fulfilled here. If that say with the same compound, if this is the carbonyl carbon, this is the alpha carbon. So that means if your corner carbon is a carbonyl carbon, this is the alpha carbon, right? No? Okay. So the connectivity is met. The carbonyl alpha connectivity is met. Right now? So we can make this one through Aldol condensation. We can make this one through Aldol condensation. See, let's write the carbonyl compound we need to react with the NaOH to come up with this greater carbon skeleton. Right? Let's write this one first of all. This is the carbonyl carbon. This is the carbonyl carbon. I just write the carbon carbon like this. This is a carbonyl carbon. Then to that carbonyl carbon, this is the only R group. This is the only R group connected. CH3CH2 group. CH3CH2 group. That is the only R group connected to this carbonyl carbon. So I'll write it like this. CH3CH2. That is the only R group. Then as this one is lack of 4 bonds, 1, 2, 3, only 3 bonds are available. As this guy is lack of 4 bonds, just write the hydrogen for the remaining bond. So actually this is the carbonyl compound, the aldehyde. Right? We need to react with the NaOH to undergo condensation to come up with the carbon skeleton. Right? Let's put the NaOH, aqueous NaOH here. They're not 11. Let's do the condensation. So first write this one. Without this 5 bond and with some hydrogen here. CH3CH2 with that hydrogen there. And this hydrogen is there. I just bit the hydrogen. And then to that carbonyl carbon, you're supposed to connect the alpha carbon of the same compound, by removing one of the hydrogens. So that only one hydrogen will be available with the alpha carbon, as you had removed one of the hydrogens to write it here. So and CH, then COH stuff will be written. And this thing is going to be bent like this. Right now? So you clearly see you had written the correct carbon skeleton now. You had came up with the correct carbon skeleton now. So you are very happy, right? So this is your heart of the question. coming up with the correct carbon skeleton. Now simple stuff to be written. Right, let's complete the conversion. Basically here the corner carbon is with the functionality. Corner carbon is with the functionality. So that's what we need to do. First you need to come up with the corner carbon as the functional carbon. So anti-Markov should be done. Let's do the anti-Markov, right? To come up with the corner carbon as your functional carbon. Anti-Markov. The R2O2 HBr. Then before going towards the oxygen compounds, first you need to come up with the alcohol. So oxygen compounds are made via alcohols, going through alcohols. Right, Br converted into OH means it is the NaOH AQ you need to add, so that this can be done easily with the use of PCC. The extraction is done. Then converting this to here, So what we need to do? We need to convert this OH to a Br and this thing to a Br. Right. First of all, let's convert this into a OH by just adding lithium aluminium hydride in dry ether medium and coming up with some acidic makeup. You can convert this aldehyde section into a alcoholic section like this. This hydrogen can be written like this, no? Simply this carbon, and this is becoming OH. Right, this aldehyde section converted to a CH2OH. That is what the lithium aluminum hydride do. Then simply adding some 2BRC, by just adding the HBr. HBr will convert these two OHs to 2BRs. Right now, so that is how the conversion is supposed to complete it. Right, supposed to complete, right? So again you see 1, 2, 3, 4, 5, 6, just 6 steps are used to complete the whole process. Right, so basically with the condensation with the aldol with the condensation we choose the aldol condensation to come up with the correct carbon skeleton. Right, so basically those are with actually steps less than 6, less than or equal to 6. Most probably that is the case, right? So another example is that, right now. So this is the aldol condensation. Right? So and I have another thing to say to you, Ramai. So let's see, when you are seeing this, when you are to see this ultimate compound, the product you had just made, when you see this product you have just made, you clearly see with this compound, the final product, these are the two functional carbons, no? In your final product, these are the two functional carbons, no? At this compound, these are the two functional carbons, right? Ultimately. So basically those are not the adjacent carbons. Some carbons bit away from each other. In your product, you have two functional carbons which are not adjacent but bit away from each other. So if you are supposed to make such kind of a compound by a synthesis process, most probably that should go through aldol or ketol condensation. Right? In your final compound, the compound you are supposed to synthesize with that thing, if the functional carbons are not adjacent, and bit away from each other, a bit away from each other, then most probably that should be done via aldol condensation. That should be done via aldol condensation. Basically, with Grignards, you can't come up with these situations, Lama. It is very hard to come up with this kind of a situation with Grignard. So if you think so, if you think much, right? If you think, you can clearly see by the Grignard connection. When you connect two compounds via Grignard, you will come up with only one carbon. You will come up with only one carbon as a functional carbon. There will be only one carbon as a functional carbon when you connect two compounds via Grignard. Only one carbon as a functional carbon. You won't see this kind of two carbons appearing bit away from each other after the connection of by Grignard method as well as by Dehydration method. So basically, if you are coming up with such kind of a compound where the two functional carbons are not adjacent and bit away from each other, most probably that should be done via the condensation. Those are some hints. To go to the condensation, right? So one hint is basically the number of steps are very limited, 6 or less, most probably 6 or less steps, right? Number of steps are very minimum. There is one hint which they are supposing you to go through the condensation, right? The other hint is basically if you are with two adjacent carbons, if you are with two functional carbons which are not adjacent to each other and which are with some distance, most probably it could be done through the condensation, right? So this is all about the condensation. You should know, right? This is all about the condensation, right? Now, so you can have a screen capture here as well for this one as well. Then we can go to the next section. All right,